I'm just gonna like
think you're in the laser or something.
go.
I might.
Board number.
Up first on the LT Spice review is going to be our transmitter circuit. In the top left, you can see that we have our mic circuit, and that is pretty similar to our Project 1. Our microphone is powered, and this goes through a capacitor, and this capacitor basically just takes out any AC voltage that our current that wire may have due to the microphone, and that goes straight into an amplifier and potentiometer 1 up on the top. That is how we control our gain factor on the microphone, and also equivalently is how we turn up and turn down the volume. On the bottom left, you see the aux circuit, and obviously we have a voltage source of our to replicate our aux input, and that goes straight into an amplifier. And again, potentiometer 2 does the exact same thing. It's how we control the gain and the volume essentially of the aux circuit. Now, both of these two circuits meet at the middle of this voltage divider that we have here, and it goes directly into a summing amplifier. Now, as a summing amplifier, it will sum them, amplify them, and also invert them. That is why right after that, it goes straight into an inverter, which obviously does as it says. It takes whatever value gets in and it inverts it on the other side. And the reason we do that is because we don't want a negative value going into our laser. And then it goes directly into the laser, and that is how we get obviously the frequency into our laser to transmit. And to give it the offset that we need, the laser is plugged into the negative 4.5. That way we have that DC offset we need in order to transmit effectively. And here you are seeing that little white dot you see right there is right where we measured in LT Spice to show the sine wave that we see in our real circuit. Right here, this is what we see in LT Spice. This is before amplification, so obviously it's a little smaller than what we hope for, but obviously that's what the amplifiers are for. And here's the video. This is our actual board in class showing our benchtop measurements. Here we have the receiver circuit. Now, the way this receiver circuit works is that we have a solar cell, and that is where the laser points. And when the light comes into that solar cell, it basically gets pushed through a capacitor, which kind of cleans up the sound a little bit, makes it sound a little better on the other side when we get to the speaker. And that goes through an amplifier, and again, potentiometer number 3 is how we control the volume and the gain on our receiver circuit. And then moving on to the 5 parallel op amps. The reason we have these is because we want to pull about a watt of power into our speaker, and the only way we can do that is by adding a bunch of these op amps in parallel, because each of them can only pull about 70 milliamps. So in order to get to our desired power output, we had to add a parallel series of all of these op amps in order to sum all the currents coming out of them, and all those summed currents go directly into our speaker, and that is how we get the output that we desired of that 1 watt power. And basically, it just amplifies the signal to a point where the speaker, you can hear through the speaker loud and clear, and that's the main function of those op amps and the basic summary of our receiver circuit. Moving on to our voltage dividers. Here we have our 2 LED indicators and voltage dividers. And as you can see, the references, we all created them using the same value resistor. We chose 1000, and our positive input for our op amp is going to be on the left. That we see is going to be the output of our summing amplifier, like the end of that shows the volume of our microphone and our aux circuit. And basically, as the summing amplifier's voltage changes, we'll see that that certain LEDs should turn on and off given the certain voltage that the summing amplifier and that circuit is pushing out. So as we increase the volume, more LEDs should light up, and as we decrease the volume, the inverse should happen. And the same exact thing happens for our receiver server on the other side. Here we have the virtual ground circuit. Now, how this works is we have a 9-volt battery, and we have to be able to transport our circuit. So the way the virtual ground allows us to do that is when we plug in our 9-volt battery, we create a small voltage divider, and effectively what this does is it allows us to get a voltage of 0 in the middle of this voltage divider. And then we push that into the positive pin of our op amp, and we create a negative feedback loop. Now what this does is we create a sort of a buffer, and a buffer essentially tries to keep the voltages of the positive and the negative output very, very close. And if we put it to 0, it's going to basically allow us to have a 0 or a virtual ground. And the also benefit of this is that the top of the circuit and the bottom of the circuit will also effectively give us a 4.5 and a negative 4.5 voltage, which is enough to allow us to use all of our op amps and circuits, and this is how we powered most of our board when we were doing demos in the hallways and in different locations. Thank you for watching my video. Hope you enjoyed.